1.7. I do not want to use up our last review day, spending the period on 1.7, because the test is more than that, and I think it would be better for us to review everything, not just 1.7. So let's see, the answers I've given you to 1.7, let me see which ones they are. I did 21 to 36. So if there's any question, I'll take just a couple of questions before number 21 in 1.7, and then I want to do some review, and then if we have time after that, we can do some other stuff. But anybody before questions, so 1 to 20. Any question on section 1.7, 1 to 20? 21 to 36, you have the worked out solutions already, so you can look at those. 1 to 20.
Can you do number 20?
Yep, I'll do number 20. Should I turn this on? I did. Okay, so I'm going to do number 20, and then I'm going to start with review sheet 1, so that we get that one done. All right, so here we go, number 20. The isosceles triangle has its base along the x-axis with one base vertex at the origin. Okay, so that tells me what's going on. Okay, so here's my isosceles triangle with one vertex at the origin. And the vertex is in the first quadrant. Oops, 6 minus x squared. Okay. Right, the area of the triangle. Okay, so what's our formula for the area of a triangle? 1/2 base times height. Okay, so looking at this triangle, this is an isosceles triangle now. Okay, so I'm going to drop an altitude down. And what does that altitude do to the base of the triangle? Cuts it in half. So I don't know, I could call, I guess I'll just call this X, and then this will be X. And this point right here, this point would be what? Here's the origin. What would be the coordinates of that point? I'm going over X and up Y. But what do I know about Y? What does Y equal? 6 minus x squared. So the height of the triangle is really 6 minus x squared. It's Y, the height is Y, but Y is 6 minus x squared, according to the problem. So the area of my triangle is 1/2 the base. Now be careful, what's the base? 2x. And then the height is 6 minus x squared. So that is x times 6 minus x squared. That's 6x minus x cubed. Now, what I have to be careful of, that's a perfectly fine formula. It is absolutely wonderful. But I have to make sure I've done what they asked me to do. They asked me to write the area as a function of the length of the base. Now, I have written the area as a function of x. Is x the length of the base? is x the length of the base? No, it's only half of it. So 2x's equal my base, right? So what does x equal? Half the base? So now I'm going to come over and I'm going to say 6 times b over 2. Why, how'd that get to be cubed? Oh yeah, it's supposed to be cubed. Over b over 2 cubed. In other words, because of the problem, not because of anything else, just because the way the problem was phrased, my answer is not good enough in terms of the x value. It has to be in terms of the base of the triangle. That's what the problem says. So I'm going to manipulate it and say, okay, the base is 2x's, so every time I see an x, I can put in b over 2. So my answer ends up being this. This is my area in terms of the base. Now, again, there is nothing wrong with this. This is absolutely correct. It just doesn't meet the picky little requirements of the problem.
Are we gonna have a question like this on our test?
Honey, yes. You need to know how to do all of these things. Yes, you do. And you'll see on the review sheets there are some things like that. Michael?
Can we do number 18?
Okay, this is the last one I'm doing it before I do the review sheet. A square is inscribed in a circle. So here's the circle. When we say we inscribe a square, we mean we make a square inside of it. So the square is inscribed in the circle. Now I'm going to write the area of the square. Okay, let's just stop right there. The area of the square. What would the area of the square be? Side square. That's in every geometry book you'll ever see published. It's a perfectly wonderful formula. But what have I done? I've written the area in terms of the side, the square, the side of the square. What does the problem say? We want the area in terms of the radius of the circle. So let me go ahead and draw in a couple of radii. Now, what's the relationship here? What's going on here? Remember that this is a square. Diagonals are perpendicular in any rhombus, including squares. So what can you tell me about that little triangle right there? It's a right triangle, which means what very famous theorem should work? So I can say r squared plus r squared equals s squared, or 2r squared equals s squared. Which means, see this guy right here? Now this was a good formula, but what was wrong with it? It has s's instead of r's. So what am I going to do? S squared is 2r squared. So instead of writing s squared, I'm going to say 2r squared. And there we go. These two say exactly the same thing. They both give me the area of the square. This one does it in terms of the sides, and this one does it in terms of the radius. So in both of these problems, we just went ahead and wrote a formula, this area of the triangle, area of the square, and then we figured out what we needed to substitute in to get the variable that they wanted. Here they wanted b. Here they wanted r. So we got our formula written, and then we figured out what we could plug in. All right, let's look at review sheet number 1, and we'll turn straight to those problems first. So let's look at review sheet number 1, and let's start on the back, because I don't know that we'll have time to get the whole thing done. So let's start on the back of review sheet 1. The very first problem at the top says David earns $2,000 a month. His rent is $450 a month. what percentage of his salary is his rent? Alright, so how are you gonna do problem 10? Please don't make it hard. Oh my gosh, it's so easy. What? What are we gonna do? We are on the back of review sheet 1, starting with problem number 10, which talks about David and his rent. Yes, the sheet says Precal A, review 1.5 to 1.7. All you're gonna do is divide 450 by 2,000 and express that as a percent. So 450 divided by 2,000. Is it? It sure is 22.5%. That's all there is to it. Do not make it hard. Number 11, how many gallons of vanilla ice cream with this must be mixed with this to get vanilla fudge with 14% butterfat? Okay, this is a mixture problem, right? I'm going to say amount. You can do it however you want. This is my strategy. It makes it simple for me, but if you have another strategy, that's okay too. You better get the same answer. Alright, so we've got a 12%. Remember, you're always going to have your percentages, and 20%, and we want to end up with 14%. So there are all of my percentages. Now, which amount do I know?
Not a chocolate.
So I know this one right here, 18. I have no idea how much vanilla I'm mixing in, right? But I do know, here's my big bucket, I'm dumping in X gallons of vanilla and 18 gallons of chocolate, so how much do I have altogether?
18.
Not 18X, 18 plus X. I have 18 gallons plus X gallons all dumped in there together. So doing my arithmetic, I should be able to get an answer pretty easily. I'm getting, and you need to confirm this to be sure, 54. Somebody match that? Everybody okay with that? Put it in the plate. Thank you, Maddie. All right. Everybody good? All right, next, we have a cylindrical tank with a diameter of 30 feet filled with gasoline. All right, so here's our cylinder. And it has a diameter of 30, which means its radius is 15. And gasoline, it's got 60, the height of it, the depth is 60 feet of gasoline. The gasoline begins draining. Okay, so somebody's opened it up down here. There's a faucet or something. Somebody's opened it up. And it's draining at 3.5 cubic feet per second. So it's coming out. Write an equation for the volume of gas in the tank after T seconds. The volume of gas that we have to start with, yeah, which may or may not be the volume of the whole cylinder, I don't know, but we got 60 feet of gas in there, and we are going to figure out how much is it, what's the volume of that gas. So how do you find the volume of a cylinder? Pi r squared H. That is the volume for a cylinder. So we know that right now, before we open it up, before we let any come out, the volume is pi times the radius squared times the height. That's how much gas is in there right now. So let's figure out what that is. Jade?
Will you give us the equations on the test?
Not for something like this.
Where's 2, 4, 11?
I'm leaving it in terms of pi to be a little more exact. I got 13,500 pi. Okay, now, that's how much gas is in the tank right now. Okay, that's what's in the tank right now. But now we're letting some out, right? So our answer is going to be this number minus something, because gas is coming out. The volume's going to be reducing, right? Now, how much is it reducing by? 3.5 cubic feet every second. So how will I express that? 3.5 T, where T is the number of seconds. If you go 1 second, out comes 3.5. If you go 2 seconds, out comes 7, and so on and so on and so on. Okay? That wasn't so bad. Number 13, describe the transformations that would be necessary to change this parabola into this parabola. Okay, so you're describing and you're using words, and we're going from this one, which by the way is what shape? What shape is that? A parabola. And it's not vertex at the origin anymore, it's vertex where? Well, it's going to go left 2 and down 8. So you got a parabola that's here at -2, -8. Everybody okay with that? Okay, that's what I'm starting with. Now I want to change that into this one. And I have to describe how I would do that. Well, that's still a parabola. Where's that one sitting? At 3, -4. Now, no matter how I have drawn them, these are exactly the same parabola. I've just moved them. So now you need to describe, okay, what are you doing? How are you getting from this one to that one? What are you going to have to do? Well, you're going to have to move it from -2 to +3, right? Which means you're going to have to move it 5 units to the right. 5 units right. All right, what else are you going to have to do to it? Well, you got to have it, it's got to go from -8 to -4. So you're going to have to move it 4 units up. Now, on one of the review sheets that I've already done, this question is there. It's on all the review sheets, which means it's going to be on the test. But on one of them, there was a negative out here. So that not only picked it up and moved it, but it also turned it upside down. So you would have a third thing listed here. Not only are you moving it horizontally and vertically, but then you're also going to have to flip it, if that had been the case. It's not in this problem, but you'll see when you do the review work, there's one that you have to also flip it. Uh-huh, yeah. All right, now, number 9. Alright, so let's look at number 9 real quick. What's that going on? Okay, we got a piece of paper that's 12 by 18, and we're going to go through our list of questions that are required for the box problem, which will be definitely on your test. So the paper is 12 by 18. And then here are the questions. There are 4 of them this time. The first question says, express the volume of the box as a function of the width of the cutouts. That's exactly how we've always set up our problems. We're not gonna change the setup. What does this mean? Write the equation for the volume. So what is the equation for the volume going to be? Length times width times height, which is what? 18 minus 2x, that's your length. 12 minus 2x, that's your width. And then x for your height. Length times width times height. So, question number 1, express the volume, da 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 da. All that's saying is, write the equation for the volume. Now, what is the domain? That means, what can x be? What are the limitations on x? Always 0, right? You can't ever be negative. And then 6, because your smallest dimension is 12. What is the maximum volume? All right, so now we go to our calculators. We're going to type in our equation. And remember, when you hit graph, you're either going to see a hill or you're not. And if you don't see a hill, it's because you don't have your window. You got to see the top of the hill. It's because you don't have your window set big enough. Mine still isn't big enough. I used 300 for my Y-max. Remember, this is X-min, X-max right here. This is X-min, X-max right there. I used 300, and that worked for my Y-max. Now, those of you that are just sitting there watching the rest of us press our buttons, I hope you are able to do this on testing. Okay, so the maximum turned out to be 2.35, 228.16, if I did it right. Anybody confirm that? Okay, so that's what I get on my calculator. So now I need to answer the question. The question is, what is the maximum volume? So looking at what the answers that I got here, what am I going to put down as the maximum volume? 228. This is y. That's volume. That's your y coordinate. So you'll say 228 cubic. I guess it was inches. I can't remember. And then question 4. What size cutouts would be necessary to have a box whose volume is 150? Jade?
So is volume always going to be y?
Okay, look, honey, look. When I wrote my equation and I said V equals, when you type that into your calculator didn't say V. What did it say? When you typed it in.
What?
When you typed in this equation on your calculator,
Yeah.
you didn't type V.
Yeah.
What was there?
Y.
What? V and Y are the same thing.
Okay.
That was V equals, but your calculator changed it into a Y.
I got it. Okay.
Right? Now, what's number 4? What's going to be my strategy with number 4?
Could you set equals
Oh, take my equation, 18 minus 2x.
It's probably easier.
Oh, no, Brenton, you are on target. Now, at this point now you do have a couple of options to solve it.
You could also like to that point.
What I would do, since you already presumably have the parabola graph, or it's not parabola, but you know what I mean, you have the hill graph, I would just go back in and add a second equation, 150, just one.
Where y equals 150.
Yeah, y equals 150, like for y2. Just set it equal to 150 and hit enter, or hit ref, I mean. And what will happen is you'll get this guy again, and then you have the 150 line drawn across it. Right?
Yeah.
So what would we be interested in?
The intersection.
Where they cross? Now, having already done question 3, this is probably the fastest way to do it. To find where it crosses, you go back into second calc, just like you've done a million times, but now, which option are you gonna choose since you're looking for the point of intersection? You're gonna go down to intersect, and it's gonna ask you to set a left bound and a right bound. So your left bound, you're gonna set the cursor, you don't get to pick, the cursor picks the curve it's on. So you're on this curve, so you just hit enter over there somewhere, and then it flips up to this curve, hit enter. So I got my cursor, I got a bound set down here and a bound set over here, and then I'll move it right back onto that point. And my first point of intersection is 0.91, 150. Now, did I know my Y would be 150? Yeah, that's how high it is. But my first X is 0.91. Now let's see if we can find the second one. Start over again. Second calc, go down to intersect. You are looking for this point, so set the cursor somewhere to the left of that point. Then set it somewhere to the right of that point, and then put it on that point. And that one is 4.14, 150. So how are we gonna answer question number 4? It says, what size cutouts? These are your cutouts. So you're gonna say, actually, there are 2 options, right? Either they're squares that are 0.91 on a side, or they are squares that are 4.14 on the side.
So it can be, like X is greater than.
No. It says, we want the volume to be
Oh, it'd be or,
150.
it'd be or.
Yeah, so it's this one or this one, period. It's not an inequality. If it said less than 150, then we would have inequality. So greater than, but this just says where does it equal 150?
So when you're putting the intersection in your calculator, would you get a different answer if you were to put the cursor starting on the curve on the right side on the left first and then go to the right?
Your answer, the cursor's gonna come up on whatever equation you put in first. The left bound is gonna be set on it. You don't get to move it. You're not switching it. As soon as you get second calc intersect, the cursor's gonna come up on the curve. If it's left bound, set it to the left of the point you're looking for. You don't need to worry about what curve it's on. It's gonna take care of that. You just get it to the left of the point you're looking for.
Okay, so save on the right, just make sure it's to the left.
Yep.
And then I was looking at it again, and since there's 3 of them where the Y intersects.
Okay, but there aren't. You have your window set bigger than 6. That's why I said you've got to pay attention to that, because your answer's not gonna make any sense. There are 2 answers to this question that make sense. These curves, if you typed in that whole equation, the volume equation, it has some funky shape. Okay, great. I don't care about any of it except this part, because that's the only part that makes sense for my box.
Okay.
Right? Okay, let's see what else we've got here. Okay, I don't have much time. Look at the rest of the front page there, this review sheet. What,
For number 1, would you just have them equal to each other, or would you set one?
for number 1, I would solve for t in the first equation.
Yeah.
So that would be what t equals from the first equation. and then I would substitute it into the second equation.
Okay.
Now, that isn't cleaned up or anything, but that's the strategy. Yeah, I think it's much easier to solve for t in the first one than it is in the second one. So I would solve the first one for t and plug it in.
Number 7, I don't understand like the inverses and the F.
Well, what does it mean to be inverses? It means they undo each other, right?
Mm-hmm.
If my job is to prove that they are inverses, the way we prove they are inverses is we do these two compositions. So, F is x plus 1 over 2, and G is 2x minus 1. So I'm going to make these two compositions, and if they work out, the answer is yes, they're inverses, and if they don't, it's no, they're not. So this means plug G into F. So I'm going to plug G into F. So that would be 2x minus 1 plus 1 over 2. Now, what happens, I'm taking my G function and plugging it into my F function. What happens to these two ones? So I have 2x over 2, which is x. That's what has to happen. So far, so good. Now I'm going to plug F into G. So now I'm plugging this into here. So it'll be 2 times x plus 1 over 2 minus 1. What happens to these two 2's? So I have x plus 1 minus 1, which is x. I just proved their inverses.
So they always have to equal x?
They both have to equal x. So if I'd have done the first one, and I got, 5x minus 6 or something, then I'm done. They're not inverses.
Okay.
Could you also do what we've been doing where we flip the x and the y?
Okay, well, no, but that, you mean basically say, okay, I'm gonna start with this, I'm gonna find the inverse. That's not a proof, okay? However, you can disprove by plugging in numbers. I thought that's where you were going. So like if you plugged a 6 in here and got 15, you don't, but I'm saying if you plug 6 in and get 15, then when you plug 15 into the other function, you better get 6, right? Now, if you do, you still haven't proved. This is the only way to prove it.
Okay.
However, Brenton, if you plugged in your 15 and got 7, that would be conclusive they are not inverses. So you can disprove with that, but you can't prove with it. This is the only way to prove it, okay? So if it says prove their inverses or explain why they're inverses, this is what you do. You make the composition. FYI, you will do that on Tuesday.
So then what was where we flipped the x and the y?
That's when we're finding our own inverses.
Just finding
Yeah,
the
so the question will say, here's F, find the inverse, okay? And then somebody already did that and got this answer. This is checking it, okay? All right, anything else on the front of the thing here? Number 6 is the same sort of thing. Only you have to find your own and then prove it. All right, let's run through there. Number 8 real quick. We don't have time to draw them all, but let's talk about what happened. Number 8. 8A. What are you going to do when you redraw your picture? The height will be 3 times as tall. So look at the original. It goes up to 3. So the new one you draw is going to go all the way up to 9. Everything's 3 times as tall. What about B? It's going to be upside down and 1 to the left. Upside down and 1 left. And again, if you can do that in 1 step, awesome. If you can't, do it in 2 steps. Bring a colored pencil, do it in 2 steps. See what's happening. The width is going to be half. So instead of the triangle being 2 across the bottom, it's only going to be 1 across the bottom. D. flipped this way, flipped this way across the y-axis, and then
Up one.
up one. And E.
All of them are even, or like, not even.
All of them are above.
All of them are above. So the triangle stays put and the trapezoid gets folded up, right? Number 2, very simple question. Is what I drew there a function? Yes. Is its inverse a function? No, no, no. Why is the inverse not a function for problem number 2? It doesn't pass the, no, it passes the vertical line test, but it does not pass the horizontal line test. Remember, when you write the inverse, you're switching the x's and the y's. So you can't have any repeated y's in the original because those would become repeated x's in the inverse. So number two, now listen. Number 2, the thing is a function. Its inverse, because it passes the vertical line test. Its inverse is not a function because it doesn't pass the horizontal line test. Meaning that it's not 1-to-1, because if you're 1-to-1, you pass both. That means no x's repeat and no y's repeat. 1-to-1. What? Okay. The original picture passes the vertical line test, so it is a function. It does not pass the horizontal line test, which means y's are repeated. So when I switch to order pairs, those will be x's repeated. Right? Yeah, I'll see you. Whoa. This is our Friday.
Whoa, she needs a hug.
This is our Friday.
You will, I need a hug.
Blair got a good
BA. You will, I need a hug.
I'm gonna do a math.
This dude doesn't know she has Claire, no water outside. It's like, what There's an actual. Wait. There's a defense and offense in this still, right? Okay. The way you make it sounds like everyone's like, you have a side partner, like, we're switching things up, you get a new person, you get to meet them, talk to them.
I don't think so.
For what? Bye.
The bus.
Football tomorrow.
Is that right, a different bus?
I have to ride their bus, so we'll see how it goes.
Their bus? No difference in our I think the video's still on, but that's
So, for like, not 1-5, we were just supposed to like find out like it was the other one that had happened. So, on one of the equations, it was like 7 over x, and then the other one was 7 over x. And you're supposed to plug it in, so like one of them is 3 over x, you know? So when you plug it in, it's 7 over 7 over x. So what does that mean? Does that
That means 7 over 1 divided by 7 over x, which is 7 over 1 times x over 7, which will be x.
Oh, okay.
You're dividing by fraction, so you're multiplying by the reciprocal.
Oh, okay. Oh, okay. Okay, that makes sense. I just